At the quantum level, particles do not behave like tiny billiard balls. They behave more like waves spread out across space, existing as patterns of probability rather than fixed objects. Physicist Richard Feynman, one of the greatest minds of the 20th century, famously said that nobody truly understands quantum mechanics, not because it is mystical, but because it defies our everyday intuitions about how things should behave. What physicists do agree on is this: at the deepest level, what we call matter is better described as excitations within energetic fields. In other words, matter is not fundamentally solid, it is organized vibration. Think of the universe as an immense spectrum of vibrational states. Different rates and patterns of vibration determine whether something appears to us as solid, liquid, gas, or entirely beyond our perception. Physicists describe fields, like the electromagnetic field or the quantum field, as fundamental to the structure of reality. Particles are not objects inside these fields. They are the fields, vibrating in particular ways. This is not science fiction. This is the standard model of particle physics, the most precisely tested scientific theory in human history. And the implication is profound. There may be vast ranges of vibrational frequency that exist in the universe, but are simply invisible and imperceptible to human senses. Not because they do not exist, but because we lack the instruments to detect them. The chair beneath you, the air in the room, the light reaching your eyes, everything you perceive as solid and fixed is, at its most fundamental level, energy in motion, vibration, frequency. Here is a humbling fact: human beings perceive only a tiny fraction of the vibrational activity happening in the universe at any given moment. Consider sound. The human ear can detect frequencies roughly between 20 Hz and 20,000 Hz, but dogs can hear up to 65,000 Hz. Bats navigate using frequencies above 100,000 Hz. There is a rich acoustic world happening around us that we simply cannot hear. Now consider light. The visible spectrum, the range of electromagnetic radiation our eyes can detect, sits between approximately 400 and 790 terahertz. Below this range lies infrared radiation used in thermal imaging cameras. Above it lies ultraviolet light, X-rays, and gamma rays. Our eyes are essentially narrow windows in an enormous wall of electromagnetic reality. What we cannot detect does not mean it does not exist.